We're going to go through a real simple example here where we tie a Velocio PLC to a AdvancedHMI program. What we'll do is we'll start out by creating a new project, and you can see here I'm going to just use an ACE222, but we can do this with any of our PLCs. We're not going to do a whole lot logic-wise because we really just need to be able to tie some data, from one side to the other side. So we'll just do one or so functions. But what we're going to do is we'll pull up the Modbus tool. We need to get some addresses to some tags so that we can interact with them on the AdvancedHMI side. So what we'll do is we'll have one input bit that will just it'll be one of our digital inputs, and in my case I have a switch tied to it, so I can turn it on and off and quickly see what's going on. I'll be able to read that on the HMI side. And we'll also take a digital output, which is we could have used a register or anything, but we'll use digital output so I can see the LED turn on when it's active. Anytime you want to write to a register, whether it's an output or an internal register, you need to be sure to have the remote writable flag checked. So now you can see it's writable, and on the for non-bit data we use this side over here. The numbers can overlap, so you can have a 1 over here and you can have a 1 over here. That's fine, no problem. So we'll read in one of our analog inputs from this board, and we'll also create something just to have a different data type. We'll call it float 1, and I'll define it as a float. And this is the one place we'll use a little bit of logic. You'll see. Let me point out the addresses so you'll have them when you get further along in this example. Wait just a second for this to pop up, and you'll see that the input bit was 1, the output was 2, the I16 input was 1, and the floating point was addresses 2 and 3. So we're going to need that in the next part of our example. But we're going to create this float by taking the output, we'll make that the float 1, and the input we'll just take in I16A1, and we'll do plus 0.1. So it's just going to be 0.1 higher than the regular input from our analog port. And now I'm going to program it, and I'm going to run it, and we will pick up with this in the second example.